So good evening to all. Are you able to hear me? Okay, it is audible. So with regard to this plant kingdom, as in case of the spermatophytes, that is gymnosperms and angiosperm. In both gymnosperm and angiosperm, the dominant plant body it is the sporophyte. It is independent, and gametophytes, which are highly reduced, dependent on what it is the sporophyte. And in case of the gymnosperm, it is having medium-sized trees and some shrubs, the herbs which are absent in case of the gymnosperm, and the unbranched stem in case of the cycas. The unbranched stem cycas, what do you call it is codex. And branched stems in case of pinus and cedrus. Pinus and cedrus, it is the branched stem. And the sporophyte is divisible into variety root, stem, and leaves. A plant with dimorphic root, it is cycas, having varieties coralloid roots. The coralloid roots, which are called phycorrhizal roots, that is roots associated with blue-green algae. What do you call phycorrhizal root? Symbiotic association, nitrogen fixation. As in case of the pinus, it is mycorrhizal. So pinus mycorrhizal, cycas it is the phycorrhizal roots. And the vascular bundle similar to that of the dicot stem, collateral, conjoint, open, and dark vascular bundle. So second growth present in the stem as well as varieties, the root, the secondary growth. And the leaves which are pinnately compound. So single rachis on either side the leaflets are present, pinnately compound. The pinnately compound leaves persist for varieties. It can withstand the temperature, the humidity, as well as varieties, the frost, wind, it can tolerate. It is having multiple epidermis and stomata it is the sunken. So sunken stomata, multiple epidermis, leaves having reduced leaf surface area, it is acicular, needle-like leaves. So acicular needle-like leaves are present in pinus. Needle-like phylloclades present in casuarina. Needle-like cladodes present in asparagus. The similarity of the casuarina and asparagus, both are varieties xerophyte. It is a dry xerophyte, it is variety succulent xerophyte. The pinus, it is a gymnosperm. So needle-like leaf, acicular, needle-like phylloclade, needle-like it is the cladode. So leaves, it can withstand the temperature, wind, and where it is the humidity pinnately compound. That is the key point. And the plant, it is a sporophyte, is going to be where it is sporophyll. These sporophylls lax or compact. What do you call lax or compact? Lax, it is the free sporophylls. The free sporophylls, and it is the fused. It is the cone axis. The sporophylls which are compactly to form, what do you call it, is the cone. Otherwise it is strawbillous. So compacted sporophylls forms what it is strawbillous or cone. Both male strawbillous and female strawbillous on the same plant in pinus. The single plant going to bear what it is male as well as female cone on the same plant. It is monoecious. The plant with a monoecious sporophyte, the sporophylls, microsporophylls are aggregated to form a compact structure. It is the male cone present in the same plant, as well as the megasporophylls are compacted to form the female cone present in the same plant, refers to it is the pinus. So there is a cone axis. Around the cone axis, the arrangement of sporophylls, it is spiral. It is also a key point. Arrangement of sporophylls on cone axis, it is spiral. If it is a lax, which are freely present, and in case of cycas, male plant form male cone, female plant bears what it is megasporophyll. It is a male plant, it is a female plant. So cycas, male plant having what it is male cone, female plant having what it is megasporophyll. So lax megasporophyll refers to female plant of cycas. Compacted sporophylls male cone refers to male plant of what it is cycas. So compacted as well as lax sporophylls are present in a plant in case of cycas. Only compacted sporophylls are present in case of pinus. So pinus is a monoecious sporophyte having acicular leaves in which pollen grains which are winged. Three features. Winged pollen grains are present in pinus. Mycorrhizal roots are present in pinus. Pinus is a monoecious sporophyte. Gametophyte, it is dioecious. Whether it is a monoecious sporophyte or dioecious sporophyte, gametophytes are always dioecious, which refers to what it is the pinus. And the pollination, it is anemophilous, the wind pollination and direct type of pollination. Why direct type of pollination in case of gymnosperm? Ovule directly receives what it is the pollen grain, so it is a direct pollination. In case of angiosperm, it is considered to be what it is indirect pollination, because stigma receives what it is the pollen, ovule receives what it is pollen tube. So ovule receives pollen, ovule receives pollen tube respectively in gymnosperms and angiosperm. So pollination, it is anemophilous, and winged pollen grains are present in pinus. The winged structure, the word it is samara. What do you call the word samara? Samaroid pollen present in case of what it is the pinus. And pollination, it is the pollen grain, it is reduced, considered to be what it is the male gametophyte, and the pollen divides to form what it is the male gametes. Male gametes in angiosperms and gymnosperms which are non-motile. There are exceptional cases like cycas, the male gametes which are motile. So the pollen, it forms what it is the pollen tube. And integumented megasporangium, what do you call it is ovule. A composite structure, megasporangium with integument forms what it is ovule. And in case of gymnosperm, unitegmic, single integument, leaving a narrow opening, it is micropyle. A mass of diploid tissue, it is nucellus. Ploidy of the nucellus, it is diploid. And one of the cells in the nucellus act as what it is megaspore, mother cell which is diploid. Megaspore mother cell undergoes reduction division to form what it is megaspore. And out of 4 megaspore, 1 megaspore become functional, undergoes free nuclear as well as cellularization, results in which gametophyte? Female gametophyte. This female gametophyte is nutritive. It acts as endosperm. Don't get confused with endosperm of gymnosperm, endosperm of angiosperm. Endosperm in gymnosperm it is a haploid because it is the female gametophyte. It is a pre-fertilized product. Even after fertilization in the ovule, it is going to be what it is haploid. In case of angiosperm, endosperm it is a triploid. Female gametophyte in angiosperm is considered as embryo sac. In this it is endosperm. So, in this female gametophyte, 2 to many what are formed it is archegonia. And archegonia is going to bear what it is the egg cell. So, the female gametophyte it is the haploid and it is multicellular. Many cells are present. So, if you compare the female gametophyte of angiosperm, the angiosperm female gametophyte having how many cell? 7 cell. Reduced. If you compare the female gametophyte of gymnosperm, many cell. So, when comparatively gymnosperm and angiosperm female gametophyte, which gametophytes are highly reduced? Angiosperm female gametophytes are highly reduced. 7 cells, here it is the many cell. Archegonia are formed. And archegonia highly reduced in size. First archegonium appeared in bryophyte, it is elaborate. Somewhat reduced in pteridophyte, much reduced in gymnosperm. In angiosperm, archegonium it is absent. So last archegoniates are going to be gymnosperm. Primitive spermatophytes are gymnosperm. Last archegoniates are gymnosperm. Gymnosperms are only heterosporous. It is right. Angiosperms are only heterosporous. It is right. So spermatophytes all heterosporous. All bryophytes are homosporous. Pteridophytes are heterosporous and homosporous. Last homosporous plants are pteridophyte. So, in this female gametophyte, endosperm, the nutritive, the archegonia having varieties, 1 egg cell. So, archegoniates includes varieties bryophyte, pteridophyte, and gymnosperm. And advanced archegoniates are said to be varieties gymnosperm. So, advanced archegoniate, primitive spermatophyte, last archegoniates are nothing but varieties, the gymnosperm. And the pollen produce varieties, the pollen tube in which what are present male gametes. In spermatophytes, pollen is a gamete carrier or pollen tube is a gamete carrier. The spermatophyte refers to both angiosperms and gymnosperm. So pollen or pollen tube is a gamete carrier. But in gymnosperm, which is male gamete carrier, it is pollen tube is a male gamete carrier. What do you call the unionities? Siphonogamy and oogamy. So siphonogamous oogamy present in case of varieties, angiosperms as well as gymnosperm. As many archegonia are present, one archegonia, that means each archegonia undergoes fertilization, we can expect more than one embryo. So polyembryony is a common feature in gymnosperm. Why polyembryon is a common feature? More than one archegonia undergo fertilization. Next, to drag the information from angiosperm. Polyembryony present in some angiosperm, like it is citrus, helium, some species. It is because of nucellular polyembryony. Some of the nucellular cells surrounding the embryo sac protrudes into varieties embryo sac and produce varieties embryo-like structures. What do you call it is? Nucellular polyembryony. Okay, it is. So nucellular polyembryony, here it is archegonium due to presence of archegonium more than it is one embryo. So endosperm, ploidy, in gymnosperm it is haploid. In case of angiosperm it is triploid. Why endosperm it is haploid? Not because of pre-fertilized product. The female gametophyte itself acts as endosperm. The female gametophyte formed from what it is megaspore. Why endosperm in case of angiosperm it is triploid? Because it is the product of what it is the pen. Pen is formed because of what it is triple fusion. In case of what it is male and female gamete, siphonogamy and what it is oogamy. So only oogamous type of reproduction in bryophyte, pteridophyte, gymnosperm, angiosperm. Siphonogamy oogamy present in gymnosperm and angiosperm. Pollen or pollen tube act as a male gamete carrier in angiosperm. Only pollen tube act as a male gamete carrier in gymnosperm. Because in angiosperm, 60% of the plant pollen shedded two-celled stage. So in 60% of the plant, pollen tube is a male gamete carrier. In 40% of angiosperm, pollen tube, it is a pollen grain. Right from the beginning, it is going to bear what it is, the male gametes. So 60% pollen tube and 40% right from what it is, the pollen grain in case of angiosperm. So in gymnosperm, the sporophyte is elaborate, gametophyte it is dependent, and the type of life cycle, what do you call it, is diplontic life cycle. Elaborate sporophyte and reduced gametophyte, that is a parasitic on sporophyte. That's why the life cycle it is diplontic life cycle. And in gymnosperm, some fern characters retained by the plant, it is the cycas. So cycas is considered as relic of the past. Why it is considered as a relic of the past? Because some ancestral characters which are retained. What are the ancestral characters? That is succinate, vernation, 1, ramenta, 3rd, archegonia, and 4th, multiciliate male gametes. So what are the gametophytic character retained in case of or it is a gymnosperm? That is multiciliate male gametes, archegonia are the fern characters, gametophytic character. What is the sporophytic fern character retained in cycas? Succinate, vernation, and what it is ramenta, which are the fern character. That's why the cycas considered to be relic of the past. In case of ginkgo biloba, dimorphic shoots. So dwarf shoot born over what it is long shoots. Dimorphic shoots present in ginkgo biloba. Dimorphic roots present in case of it is cycas. Okay. And in case of what it is angiosperm, the advanced spermatophytes are said to be what it is angiosperm. The angio word itself conveying a vessel. So concealed, in which the ovules which are concealed, that is the fruit formation. In gymnosperm there is no fruit. Why there is no fruit? There is no ovary. Why there is no ovary? Carpels are which is not folded. If carpels are folded, there is a formation of ovary. Ovules are enclosed in it. So carpels which are not folded, it is unfolded. Ovules are directly exposed. If carpels which are folded, ovules which are concealed. So carpels folded in angiosperm. That's why ovules are concealed inside the ovary. In angiosperm, herbs, shrubs, trees. Some plants, even it is without perianth. So without perianth, it is achlamydious. And in case of angiosperm, dicots and monocot. We can differentiate based on the root, based on the stem, based on the flower, based on what it is anatomy. Based on the root, taproot and fibrous root. And based on the stem, internal character, collateral, conjoint, open vascular bundle in case of the dicot, closed vascular bundle in case of monocot. As regard to the leaf, reticulate venation and dicot, parallel venation in case of monocot. In case of flower, tetramerous or pentamerous in dicot, only trimerous in case of it is monocot. And perianth it is called tepals in case of it is monocot. Indistinguishable perianth, what do you call it is tepal. So in this sporophyte, root, stem and leaves, general features, root, taproot in dicot, fibrous roots in case of it is the monocot. So collateral conjoint vascular bundles are present in case of dicot as well as monocot, open in case of dicot, closed in case of it is monocot. So collateral conjoint open vascular bundles are present in dicot, closed vascular bundle in monocot, stems, dicot leaf as well as what it is monocot leaves. And with regard to this sporophytic structure, andrecium consists of the stamen. Anthers are dithecous, having two theca, two lobes, and 4 microsporangia. And microsporangia further mature into what it is pollen sac, that is going to bear pollen mother cell. Each pollen mother cell undergoes reduction division to form haploid microspore held in a tetrad. Latter breaks to release what it is microspore called pollen grain. And these pollen grains are carried by different agents. In case of gymnosperm, only it is anemophily. In this anemophily, zoophily as well as what it is hydrophily. And pollen develop into male gametophyte. This male gametophyte having how many cells? 3 cells. 1 vegetative cell, 2 male gametes, which passes through the stigmatic surface and stylar canal or stylar tissue to reach ovary, then what it is ovule. In each ovule, one embryo sac it is formed. This embryo sac is going to bear the how many cells? It is 1, 2, 3, 4, 5, 6, 7. 7 cells. What is the ratio of the cells of male gametophyte to female gametophyte? 3:7. What is the ratio of gametes of male gametophyte to gametes of female gametophyte? It is 1 egg cell, 2:1. What is the ratio of vegetative cells of male gametophyte to vegetative cells of female gametophyte? Here it is 1, here it is 3. Vegetative cells, otherwise it is antipodals in this question. So 3 cells, here it is 7 cells. 2 male gametes, it is 1 female gamete. 1 vegetative cell, here it is the 3 vegetative cell. So in angiosperm male and female gametophyte, which gametophyte is parasitic? Both gametophytes which are parasitic. Which gametophyte is highly reduced? Male gametophyte is highly reduced, that is 3 cells when compared to female gametophyte, that is 7 cells. So if we compare this male female gametophyte and female gametophyte of gymnosperm, which gametophyte having many cell? Female gametophyte of gymnosperm having many cell. So what is the ratio of female gametophyte of angiosperm, female gametophyte of gymnosperm? That is 7:many. What is the ratio of female gamete in female gametophyte, female gamete in female gametophyte of gymnosperm? Here it is 1. Many archegonia present, many egg cells are present. So 1:many. So one of the male gamete unites with the egg cell to form what it is the zygote, that is syngamy. And second male gamete unites with the polar nuclei to form what it is the pen triple fusion. So how many nuclei which are involved in the 2 fertilization, double fertilization? 5 nuclei which are involved. So in double fertilization, 5 nuclei. In these 5 nuclei, 3 maternal, 2 paternal. In these 3 maternal, 1 egg cell, 2 polar nuclei. So, 5 genomes which are involved in case of the double fertilization. In first fertilization, how many gametes which are involved? Male gamete and it is one female gamete. The 2 nuclei which are involved. In second fertilization, 2 plus 1, it is the 3 nuclei which are involved. Total it is 5 nuclei it is involved. So double fertilization results in endospermic seed. Endosperm provide nourishment to embryo. Nucellus provide nourishment to embryo sac. So endosperm it is diploid. Nucellus it is diploid. The similarity it is both it is nuditive. In case of it is angiosperm. And type of the life cycle in this is diplontic life cycle because elaborate sporophyte and gametophyte is few-celled dependent on what it is sporophyte. That's why it is diplontic life cycle. So in angiosperm and gymnosperm, the type of the life cycle it is diplontic life cycle. Diploid independent sporophyte having few-celled gametophyte, nothing but what it is diplontic life cycle. And in case of whether it is haploid plant or a diploid plant, it produces haploid gametes. Haploid plant divides by mitosis to produce haploid gamete. Diploid plant by meiosis produce what it is haploid gamete. Gametes are the direct product of meiosis. It is going to be wrong. Gametes are never going to be the direct product of what it is the meiosis. By meiosis, spores are formed. Spore germinate and develop into gametophyte. That gametophyte is going to produce what it is the gametes. Okay. Okay, it is. And in case of what it is type of the life cycle, in algae and fungi, zygote it is meiocyte. The zygote undergoes meiosis to produce what it is meiospore. This meiospore develop into what it is gametophyte. This gametophyte in case of algae and fungi perform vegetative, asexual as well as what it is the sexual reproduction. Which is the meiocyte in case of algae and fungi? Zygote. No free-living sporophyte. The sporophyte represented by single-celled zygote in case of algae and fungi. In most of algae and fungi, the type of life cycle it is haplontic life cycle. Exceptions are there. Diplontic in case of what it is fucus. Haplodiplontic in case of what it is laminaria and Polysyphonia. It is haplodiplontic. In case of algae and fungi. And in case of the bryophyte and iridophyte, haplodiplontic life cycle. In bryophyte, haploid stage is gametophyte that is independent and dominant. Upon which the sporophyte it is parasite. As both haploid gametophyte and diploid sporophyte which are present, the type of life cycle it is haplodiplontic. In haplodiplontic of bryophyte, which is independent, gametophyte is independent. Which is dependent, sporophyte is independent. And in case of pteridophyte, that is also haplodiplontic life cycle. In that haplodiplontic life cycle, which is dominant, sporophyte is dominant. Which is independent, sporophyte is independent. And gametophyte is also what it is independent. So haplodiplontic life cycle. So haplodiplontic life cycle in a group of the plant in which independent gametophytes are present as well as independent sporophyte means it is pteridophyte. Haplodiplontic life cycle in which independent gametophyte and dependent sporophyte in case of what it is bryophyte. And in case of spermatophyte, the type of the life cycle it is diplontic. Independent sporophyte, dependent or parasitic gametophyte which are highly reduced. So reduced parasitic gametophytes in spermatophyte. Independent gametophyte in bryophyte as well as what it is pteridophyte in case of what it is algae. First time gametophyte became independent in algae. In bryophyte, which is independent? Gametophyte is independent. Which is dependent? Sporophyte is dependent on gametophyte. In pteridophyte, which is independent? Sporophyte is independent. Gametophyte it is also independent. And in case of spermatophyte, which is independent? Sporophyte is independent. Which is dependent? Gametophyte is dependent. In algae, bryophyte, pteridophyte, spermatophyte, sporophyte is highly elaborate in spermatophyte. In algae, bryophyte, pteridophyte, and spermatophyte, gametophyte is highly elaborate in bryophyte. Many-celled, multicellular in case of bryophyte. And in case of the reproduction, in case of what it is the general reproduction case of what it is organism, okay, it is and in case of reproduction in organisms, okay. Okay, in case of reproduction organisms, just follow the discussion in case of reproduction organism. In very first introductory part of what it is reproduction organism, the biology in essence is the story of the life that is nothing but what it is, the form, the function, and evolution, the diversity, everything about the organism, it is the biology. And organism survives the millions of what it is the years. The species survives millions of the years unless threatened by natural and anthropogenic extinction. What is that meaning? The natural catastrophes like earthquakes, the tsunamis, and anthropogenic interference, the human interference, leads to what is extinction of the species. Extinction is not an instantaneous process, it is a slow process. You see, following are the sequential changes due to natural catastrophes, anthropogenic interference with regard to the organisms and species. A. Declinement. B. Endangerment. C. Extinction. First it is declinement, then endangerment, going to face the disappearance, the fear of the disappearance, and it's going to disappear. Extinction finally what it is disappeared. And dash is a vital process for continuation of species. Nothing is permanent, but life continues to exist. Nothing is permanent, but life continues to exist. That refers to what it is reproduction. So vital process it is reproduction. Organisms are adapted to reproduce, some by asexual, some by sexual mean. So adaptability to wide range areas is possible by means of sexual reproduction than in case of it is asexual reproduction. Test tube fertilization by measuring the development of. The test tube fertilization means development of seed, in vitro fertilization of exposed ovules in culture. What do you call it? Test tube fertilization. Intra-ovarian pollination. This is also development of the seed, but stigmatic pollination of the pistils when grown in case of it is the culture medium. What do you call it? Is intra-ovarian pollination. Stigmatic pollination when intact pistils, or pistils which are made to grow in case of the nutrient medium, ovule develop into the seed. What do you call it? Is intra-ovarian pollination. Already test tube fertilization. And with regard to this life cycle, there is no correlation between what it is the size and what it is life of organism. If we take the parrot and the crow for the 15 years, the parrot for what it is 140 years, and the peepal tree, Ficus religiosa, it can live for a long time than what it is the mango, which lives for the 400 to 500 years. And type of reproduction dependent on A. Habitat, B. Internal physiology, C. Genetic constitution, D. Other factors. All factors contributing for the type of reproduction: habitat, internal physiology, genetic constitution, and other factors which are responsible for what it is reproduction. Asexual reproduction never involves the gamete formation. That is going to be wrong. Asexual reproduction may or may not involve what it is gamete formation. Gamete may or may not form, but there is no gametic fusion in case of what it is asexual reproduction. Asexual reproduction always it is one individual. Sexual reproduction may be one or otherwise it is the two individuals. Not it is mandatory that sexual reproduction involves for it is the two organisms. In amoeba, nucleus divides, that is karyokinesis, and cytoplasm divide, that is cytokinesis. So it is by means of or it is the fission. Zoospores in Chlamydomonas are A. exogenous, B. endogenous, C. haploid. It is endogenous, haploid, biflagellate, anterior, and pyramidal in shape. So haploid, biflagellate, pyramidal in shape, and it is endogenous, produced in case of what it is algae as well as the fungi. It is the zoospores. And the zoospore can directly germinate and develop into what it is organism. Ploidy of zoospore is haploid. Ploidy of zygospore it is diploid. Zoospore is product of asexual reproduction. Zygospore is the product of what it is sexual reproduction. Whereas zoospore directly develop into organism, whereas zygospore undergoes meiosis to produce what it is spores. Bulbil in agave is a modified dashboard gives dash. It is a modified floral bud that is going to give what it is the branches as well as the leaves. Vegetative buds are present in case of Dioscorea. Floral bulbils are present in case of agave. In agave, floral bud destined to give what it is the flowers. But after modification, floral bud becoming what it is the floral bulbil. But this bulbil giving what it is the branches and the leaves. The question it is like this. In case of agave, the bud destined to give what? The floral bud destined to give what it is flowers. But now giving after modification it is only branches and leaves. And if we take potato, ginger, banana, and that is the rhizome, corm, stem tuber, bulb. What is the reason for the development of the plantlets especially from the nodal region? At nodal region, the buds are formed, actively dividing cells having what is meristematic cells. At the nodes of the ginger, adventitious roots are formed. At nodes, it is having the buds, meristematic cells. Epiphyllous buds in bryophyllum are adventitious. Okay, it is. Yes. Adventitious buds are formed other than the axils and terminal position. Normal position of the buds, axillary as well as terminal position. Other than axillary terminal positions, it is adventitious birds. Birds in potato which are, in case of potato, it is nodal axillary birds. It is not adventitious birds, nodal axillary birds in the case of potato. So, which are nothing but it is eyes. Eyes are vegetative propagating structure. What are present in eyes? It is axillary birds. And in case of what it is the Eichhornia. The Eichhornia introduced into India as a aquatic ornamental plant because of the beautiful leaves and beautiful flowers and shapes of what it is the leaves. Why it refers to the shapes of the leaves means pulvinous petiole. Pulvinous petiole present in Eichhornia. Pulvinous leaf base present in Fabaceae. It was introduced because of beautiful flowers, shapes of leaves, pulvinous petiole. As it was introduced as an aquatic ornamental plant because it is beautiful flowers, but it is acting as what it is a weed. Elimination, get rid of Eichhornia, different because of the two reasons. Because it was introduced plant, it is not having its predators, and it is rapidly multiplied by means of what is offshoots, that is offsets, which are propagated very extensively, divides by means of mitosis. Once it was appeared in Neet. Offsets, what type of the division occurs during the rapid propagation, that is nothing but what it is mitosis. An axillary branch of one internode length having rosette of leaves on upper surface, tuft of adventitious roots on its lower surface is nothing but what it is offset. So whenever offset break help in what it is vegetative propagation. And in case of conidia in Penicillium, which are exogenous haploid in chains. Yes, it is exogenous haploid and it occurs in the chain formed on what it is conidiophore. Conidiophores are multicellular or unicellular, multicellular. Branched or unbranched, it is branched. That Penicillium is a member of what it is Ascomycetes. In Ascomycetes, sexual spores are endogenous. Asexual spores are, it is exogenous. Asexual reproduction term unambiguously used for plants, animals, both. Asexual reproduction unambiguously, without any confusion, without any doubt, used for what it is animal. The same asexual reproduction plant can be considered to be what it is vegetative reproduction. And juvenile phase that refers to what it is animals, and same juvenile vegetative phase that refers to what it is the plants. And Neela Kurinji last time flowered during, it is September and October, it is 2018, September, October 2016. Earlier it is 2000, it is 12, 2006, later it is 2018. Statement 1. Clear-cut demarcation of the juvenile and reproductive senescent stages not seen in polycarpic perennial plant. Yes, we cannot demarcate the juvenile reproductive senescent phases because it is a polycarpic perennial plant. Polycarpic perennial plant. And if you take mango, vegetative stage, flowering, interflowering, flowering, and senescence. Because of what it is interflowering stage, recovery phase, we cannot demarcate vegetative reproductive phases. So clear-cut demarcations is not possible. Lifespan it is what it is higher. Statement 2. Interflowering stage present. That's why there is no clear-cut differentiation of vegetative and reproductive phases. Okay. Choose correct from the following. Morphological, physiological changes prior to active reproductive stage. Okay, in case of the plants as well as animals as well as humans. Reproductive phase, in case of the humans, what we call puberty. And birds lay eggs all through the year. The statement in this option, some birds all through the year. Okay, it is right. Mostly it is seasonal. So the most of the birds lay eggs which is seasonal, and some birds all through the varieties year. Frogs and lizards are seasonal breeders. Okay, frogs and lizards which are seasonal breeders. Choose correct from the following. Birds in nature lay eggs seasonally. It is the common feature. Birds lay eggs seasonally. It is the common feature. Birds in captivity, irrespective of the season. That is a commercial exploitation. Okay. Laying eggs is not related to reproduction in natural condition, captive condition, under captive condition. Okay. Following changes noticed in female placental mammals. Cyclical changes. A. Activates ovaries. Okay. Activity of accessory ducts. Okay. Activity of hormonicities. Okay. And choose odd one with regard to estrus cycle. Non-primate mammals, seasonal breeders, endometrium reabsorbed, sex urge increased, blood flows in this cycle. It is odd one. As far as what it is estrus cycle concerned, blood flows in this cycle. All grows old without exception. That is going to be wrong. When you reach the old stage, it leads to what it is the death. But death it may happen at what it is any stage. So all grows old without exception. It is going to be wrong. So mortality is inevitable. But certain organisms which are immortal, unicellular organisms which are immortal. Why? Parental plant body is distributed among what it is progeny cells. An organism finds life even at the edge of the knife. That refers to what it is planaria. What do you call it? True regeneration. Cut fragmented body again develops into what it is own organism. So organism finds life even at the edge of the knife. That refers to planaria. Can observe true regeneration. End of reproductive phase considered as one of the parameter of what it is the senescence. Okay, right? Following refers to sexual reproduction organism. Fundamental dissimilarity, that is going to be wrong. There is a fundamental similarity. Organism exhibit great diversity, microscopic, macroscopic, autotrophic, heterotrophic organism. They may differ in case of internal physiology. But as far as the sexual reproduction concerned, there is a fundamental similarity. There is a union of what it is gametes. That's why sexual reproduction is highly complex, elaborate. Why complex and elaborate? Gametes has to be formed. Gametes has to be fused. Gametes has to be transferred and fused. That's why it is elaborate, complex and a slow process. Fundamental similarity, okay. Structures associated are different. Yes, structure associated which are different in different organism. Tadpole shaped male gamete refers to humans. It is diagrammatically there in NCERT text. Pyriform male gamete refers to fucus. Pyriform male gametes, long flagellum, short flagellum, is insertion is apical, basal or lateral? Lateral insertion. And so in this list of the plant, cucurbita, ricinus, maize, sphagnum, Polytrichum, Cycas, Vallisneria, Markhantia, Khara. Cucurbita and Pinus. The list of the plant, whatever the question comes, it is going to be in the list of the plant. We can trace how many sporophytes are there, how many gametophytes are there, how many dioecious, how many it is monoecious, one by one. Cucurbita, it is a sporophyte, monoecious sporophyte, but gametophytes which are dioecious. Ricinus, monoecious sporophyte, gametophytes are dioecious. Maize, monoecious sporophyte, but gametophytes are dioecious. Male flowers packed into male inflorescence, what do you call? Tassel. Long silky styles with stigma in the female flower packed into female inflorescence, what do you call? Cob. So, tassel and cob, the male and female respectively, refers to the maize. So, monoecious sporophyte, dioecious gametophyte refers to it is maize. Sphagnum, it is gametophyte. Monoecious gametophyte. In which sporophyte which is dependent. Polytrichum, which is also what it is, the moss plant Bryopsida member. It is monoecious gametophyte. Sphagnum, Polytrichum, Funaria comes under monoecious gametophyte. Cycas, dioecious sporophyte and dioecious gametophyte. Vallisneria, dioecious sporophyte, dioecious gametophyte, and it is a hydrophyte. Markhantia, that belongs to liverworts. The plant body is a thallus, dorsiventral, attached to the soil by means of what it is, rhizoid. Antheridophore formed on male thallus, archegoniophore formed on female thallus. So it is dioecious gametophyte. Antheridophore, archegoniophore on the same plant in case of Sphagnum, Polytrichum as well as Funaria. Khara, it is an algal member, chlorophycean member, monoecious gametophyte. In case of Khara, monoecious gametophyte, having upper it is Hugonium, lower it is Antheridium. It is Hugonium. Otherwise, what do you call? Nucleus. It is Antheridium. Otherwise, what do you call? Globule. Upper Hugonium, lower Antheridium. Upper nucleus, lower it is globule. And these are multicellular and jacketed. There is a cover over this, jacketed. So in alga with multicellular and jacketed sex organs in case of Khara. So a whorl of branches at the nodes, upper Hugonium, lower Antheridium, monoecious gametophyte, all refers to Khara. And Pinus, monoecious sporophyte, dioecious gametophyte. Okay, it is. And date palm is also what it is, dioecious. Date palm, it is dioecious. Pistillate flower and pistillode flowers present in. Pistillate flowers in case of what it is, the female flower. Pistillate, it is fertile. Pistillate, pistillode. Staminate, staminode. One gynoecium, one to many pistil or carpel. Okay, it is. So pistillate flowers and pistillode flowers present in plant. Both pistillate and pistillode flowers present in ficus. Pistillode flowers, what do you call it is? Gall flowers. And sterile staminate, it is fertile. Staminode in case of varieties cassia. So cassia having staminate as well as varieties staminode. And homothallic in fungi, that refers to in case of the plant monoecious and bisexual condition in case of varieties the plant. Heterothallic in fungi refers to variety dioecious or unisexual in case of varieties the plants. Bisexual hermaphrodite animals are earthworm, tapeworm, sponges, leeches, all which are varieties bisexual animal. Diagrammatically there in case of the text. And cockroach is a unisexual species, right? And sweet, that is sweet potato, it is having bisexual flowers. Following refers to Kara. A. Chlorophycin member, right? B. Upper Oogonium, right? Lower Antheridium globule, right? Whole of branches at nodes, it is also right. That refers to varieties the Kara. And type of the pigments it is chlorophyll A and chlorophyll B. A rose plant has a bisexual flowers. They seldom produce fruits. It is having flowers. They seldom, very rarely produce the fruit. What might be the reason? There are many reasons. No viable pollen, maybe the reason, right? No functional egg, maybe the reason it is right. Abortive ovules, some ovules which are abortive. Abnormal meiosis, okay. Self-incompatibility, okay. Internal barriers. There are some internal barriers, so fertilization is prevented, so there is no formation of varieties, the fruits. Choose incorrect from the following. It appeared in the Neet once. Majority of the organism, male gamete is motile, female gamete is non-motile. In majority, male gamete is motile, female gamete is non-motile, that otherwise it is stationary. In few algae and fungi, both gametes are motile. It is also mentioned in the text as diagrammatically. Both gametes are motile. After plasmogamy, it is having 4 flagella. And after formation of the zygote, the flagella disappears. Plasmogamy followed by karyogamy in some algae. Male gametes produced 1000 times greater than the female gamete, right? Because male gamete has to be passed to reach what it is the egg. To compensate the losses, the male gametes has to be produced thousands in number than the female gamete. Dash plant of the Fabaceae is self-compatible. In pollination, pollen grain transfer to the stigma easily. Self-compatible, that is Pisum and Lathyrus, that is self-compatible, self-pollination. Self-incompatible, Ebutilon, orchids, it is self-incompatible. Dash and dash words are frequently used interchangeably in sexual reproduction. Syngamy and fertilization, the words which are used interchangeably in case of reproduction. Choose correct with regard to the parthenogenesis. Unfertilized male gamete develop into organism, that is going to be the wrong. Unfertilized female gamete develop into what it is organism, okay, parthenogenesis. In some organisms, syngamy fails, then parthenogenesis occur. Yes. The gamete is about to fuse with other gamete. Due to some barriers or internal barrier, it failed to unite with other gamete, develop into what it is parthenospore. What do you call the development? It is parthenogenesis. Parthenogenesis present in some lizards, okay, turkey birds, okay, rotifers and honeybees, okay, it is. In spite of sexual reproduction in honeybees, produce both haploid and diploid individuals. Okay, it is right. So in next session, we will discuss the rest of the bits in case of the reproduction, and we're going to start the sexual reproduction. Again, we discuss all the things present in sexual reproduction with the previous questions. Okay, thank you.